Marine scientists are interested in tidal information such as the pH level of the water, the temperature of the water, and when the water level is at high tide and low tide. Based on this kind of information, they can study the impact on ocean creatures. In this video, we are going to introduce a capacitive level detector to help determine high and low tides. In order to use the capacitive level detector in the water, marine scientists place it on an artificial mollusk. The detector is used to send a signal to other systems, such as the pH reader, to turn on and off depending on the tide.
To determine high and low tides, a sensor that will detect the change in water level is necessary. This tutorial video demonstrates the change in capacitance of the parallel plate capacitor to detect the presence of water surrounding the plates. The equation capacitance equals epsilon times the area over the distance between the plates was used to find the capacitance of the capacitor. Epsilon is a constant determined by the substance between the plates. The value of epsilon of water is 80 times bigger than the value of epsilon of air. Therefore, the capacitance of the plates in water is bigger than the capacitance of the plates in air.
To build a circuit that will detect this change in dielectric and use it to send a signal, we use an Arduino board as well as the built circuit. A 5-volt square wave input signal is transmitted from an Arduino board to the parallel plate capacitor. The parallel plate capacitor is connected in series to a resistor. This connection allows us to access the voltage drop across the resistor, as it changes due to the capacitor's voltage. A buffer takes in this voltage with high impedance and outputs the same voltage with low impedance. Connected in series with this buffer is an IN914 diode to ensure there is no backflow. This diode is in parallel with a grounded capacitor that makes up the peak hold detector subsystem of the circuit.
This is used to hold the voltage long enough to be read by the Arduino board. When the input square wave is low, the Arduino board allows the capacitor C2 to discharge. The total capacitance of the parallel plates is very small. Its value is around 0.06 nanofarads in air and around 0.17 nanofarads in water. In the circuit we built, without the use of an op-amp, the change in capacitance would cause a change in voltage that is too small to detect. However, we included an op-amp to amplify the output signal. Furthermore, resistor R4 is connected to the output signal, as well as an LED. The LED turns on and off depending on whether the output signal is high or low. The following equation shows the total gain of the op-amp. The gain is equal to 1 plus resistor R2 over resistor R3.
Here is the final schematic for the circuit. Note the nodes P0, P1, and P2. They are all connected to the Arduino board. Node P2 is connected to the peak hold detector. The Arduino board acts as a switch that allows the capacitor C2 to discharge when the switch is closed.
To build the circuit, we began by building a parallel plate capacitor. We got 2 strips of copper, soldered wire to them, and stuck them onto an acrylic backing next to each other. That completed the building of the capacitor. Then, we assembled the circuit according to the schematic and connected it to the Arduino board. The Arduino board sends out the square wave at node P0, it discharges the capacitor in the peak hold detector at node P2, and reads the output of the entire circuit at node P1.
As shown in this flowchart, the Arduino initially configures the pins. It opens the switch and sets P2 to floating. The capacitor can now discharge. It outputs node P0 as high at 5 volts, then it reads the output of the circuit P1 and displays it on the computer screen. After doing so, the output P0 is set to low at 0 volts. Finally, the Arduino board closes the switch and allows the capacitor connected to P2 to discharge. There is some time delay, and since this is all run in a loop, it runs continuously.
This is our final product. In order to make sure our circuit worked, we installed the LED connected to the output, which, as explained before, would turn on if the output were high. The Arduino's output screen would also display the exact value of the output voltage, as shown. Notice how the voltage value changes depending on whether the capacitor is in the water or not. This proves that the circuit successfully detects a water level.